What if I told you, the very moment you finish watching this video, you might already be traveling through time? It sounds impossible, but in a way, you already are. Every passing second carries us into the future. The real question is, can we go faster? Can we go backwards? Time travel isn't just science fiction. It's a possibility hidden deep in the laws of physics. And it may change the way you see reality forever. Stay with me, because what you're about to discover will make you question everything you thought you knew about time. We usually think of time as a clock ticking on the wall or a calendar flipping days. But physicists see time as something much deeper, another dimension, woven together with space itself. Albert Einstein changed everything when he introduced the theory of relativity. He showed that space and time are not separate. They form a single fabric, space-time. And here's the shocking part. This fabric isn't fixed. It bends, stretches, and twists under the influence of gravity and speed. Imagine sitting inside a spacecraft, racing close to the speed of light. For you, only a few minutes might pass. But back on Earth, entire years could go by. This isn't theory anymore. It's been measured with satellites and atomic clocks. Time itself can run differently depending on where you are and how fast you're moving. To make this real, let's talk about one of the strangest thought experiments in physics, the twin paradox. Picture this: two twins, Alex and Jordan. Alex stays on Earth, while Jordan blasts off in a rocket traveling near light speed. When Jordan returns, they're younger than Alex, maybe by years. Both experience time, but at different speeds. This isn't science fiction, it's a consequence of relativity. And astronauts in orbit already experience tiny versions of this effect. They actually age a little bit slower than people on Earth. So in a sense, time travel to the future is already real. But what about the past? That's where things get mind-bending. The equations of general relativity suggest something extraordinary: wormholes. Think of them as tunnels through space and time, connecting two distant points with a shortcut. Step in one end, and in theory, you could step out not just in another galaxy, but in another era. Sounds thrilling, but there's a catch. Wormholes would require exotic matter, strange forms of energy we've never seen, to stay open. Without it, they collapse instantly. Still, many physicists believe wormholes remain one of our best chances at true time travel. And here's the kicker: if wormholes exist, they might already be out there, hidden in the universe, waiting. Of course, traveling through time isn't as simple as stepping into a tunnel. It leads us straight into some of the strangest paradoxes you can imagine. Take the grandfather paradox. If you traveled back in time and prevented your grandfather from meeting your grandmother, would you even exist to go back in the first place? Or the Bootstrap paradox. What if you traveled back and gave Shakespeare a copy of his plays, and he published them as his own? Who actually wrote them? You or Shakespeare? These puzzles reveal how fragile our understanding of time really is. And some scientists believe paradoxes prove that time travel to the past may be impossible. Others think it simply means we don't yet understand the full picture. But here's where things get even stranger. Some theories suggest that paradoxes could be resolved if time travel creates alternate timelines. Instead of changing your past, you'd simply branch off into a new reality. Kill your grandfather? The original timeline remains intact. You've just jumped into a parallel universe where you were never born. This is where science meets the multiverse theory, and suddenly, time travel feels less like breaking reality and more like navigating a cosmic web of infinite possibilities. It's a concept that fuels countless movies and shows, but in physics, it might actually make sense. So, could we ever build a time machine? In principle, Einstein's equations allow it. If we had the ability to manipulate black holes, wormholes, or unimaginable amounts of energy, the door isn't completely closed. But in practice, the challenges are beyond anything humanity can achieve today. Yet consider this: 100 years ago, the idea of splitting an atom sounded like magic. Today, nuclear power exists. 50 years ago, a handheld computer seemed impossible. Today, it's in your pocket. Who's to say what breakthroughs await us in the next century? Time travel captures us because it's not just about physics, it's about ourselves. It's about regret, curiosity, hope, and the endless what-ifs that make us human. Maybe one day, we'll unlock the universe's secrets and step through time as easily as we cross a street. Or maybe time travel will remain forever, just out of reach, a mystery that reminds us how fragile and fleeting every second truly is. Either way, the journey into this question changes us. So, if you could step into a time machine right now, where would you go? The future or the past?